Now, an exercise in completing the square, we're asked to write the following in the form x plus b squared plus c, or with a coefficient out the front of the bracket. So we're completing the square. So if we start with the first one, x squared plus 4x minus 3. Right, in the bracket we know that it needs to be half of the coefficient in front of the x term, and half of 4 is 2. So it must have, the original expression must have come from an x plus 2 all squared. Now just underneath lightly we'll expand that, x squared plus 4x plus 4, and we need to compare this expression with the one above that we're trying to get. So once we've squared this, I can see that I've got an extra plus 4. I actually want minus 3. So from the end of this I must have subtracted 7. So we need a minus 7 there. Now for some people that's a bit of a jump, and when we get to harder examples it's good to have a method or a strategy to fall back on. So I like to think that once I've expanded it, I don't want the 4 from the expansion. What in fact I want is a minus 3 term. So just have a look at that and think about that, and you can see that we're going to end up with x plus 2 all squared minus 7. This will help us later on for harder examples, which we might jump to now, and we'll try. For example, we need to do one with a negative, so we'll try not with a negative, with a fraction. So this time we're asked to complete the square on x squared minus 3x plus 1. Now in my bracket, I know it's going to come from x minus, now we need to halve the 3. It's tempting to write 1.5, but if you stick with fractions, it makes the second part, when we have to actually solve equations using complete the square method, it makes that so much simpler and neater. So we're going to work with fractions and we're going to persevere. So this has come from x minus 3 over 2 squared. Now underneath we'll just do a little light expansion. I'll get x squared minus 1.5 minus 1.5 will be minus 3x, which is good because that's what I want up above. And let's think on the end, when I multiply that by itself, I'll end up with a positive 9 over 4. Now I'm trying to equate the bracket form with the expanded form above. I can see that I've got this extra 9 over 4. I don't actually want the 9 over 4 from the expansion. What I want is plus 1. And that way it makes it easier to work out the coefficient on the end. If I just move up over here, it must have come from x minus 3 over 2 all squared. Now doing a bit of fraction work, 1 is actually 4 over 4. We can write 1 as 4 over 4. So minus 9 quarters plus 4 quarters. Minus 9 plus 4 would be minus 5 quarters. I can see that I've written it in the form asked for. We'll try another one of those with the odd number. So we'll try f. X squared plus 7x, and of course you'll be setting it out with more space on a piece of paper. Right, I know that it's come from x plus, now we need to halve that, and it's tempting to write 3.5, but if you persevere working with the fractions you'll find it neater and quicker. Now, quickly expanding that, it must expand to x squared plus 7 over 2 plus 7 over 2, or 3.5 plus 3.5 will be 7, which is good. And from the expansion I get an extra 49 over 4. 7 squared over 2 squared when I expand that. Now I don't want the 49 over 4 from that expansion. What I do want on the end of the x squared plus 7x is a minus 3 term. So neatening that up, doing a little bit of fraction work, we're going to get minus 44 over 4. Now 12, I can write 3, as 12 over 4. So So we get minus 49 minus 12, which should be minus 61 over 4. It's a little bit of fraction work and you don't actually need a calculator. Right, we'll try one with the coefficient in front. So let's try G, and of course you'll be setting this out on a piece of paper. Now what we'll do is we'll pull out that 2 and treat it like a common factor. Even though it doesn't go into 3, we're going to pull it out in front, leaving me with x squared plus 4 divided by 2 is 2x, minus, now we must get 3 over 2. Because when I expand that, I'll get left with the minus 3 term on the end. Okay, now what I'm going to do is change to a big square bracket, and you'll see why, and at the top of it, we'll complete the square just on the bracket here. So half of 2 is 1, it must have come from x plus 1 all squared. And down below, I'll just quickly expand that, x squared plus 1x plus 1x will be 2x plus a 1 on the end. Now, I don't want that plus 1 term from the expansion. What I do want, in fact, is a minus 3 over 2 term. Right, so that means I'm left with x plus 1 all squared. Now 1, we can write that as 2 over 2. 1 is just 2 over 2, so I'll get minus 2 minus 3, which is minus 5 over 2. And you can leave it like that. It does ask us to write it in this form, so that means we need to expand the 2 now and multiply both the terms in the square bracket by the 2. So I'll get left with 2 times x plus 1 all squared minus, that 2 will cancel with that 2 when I expand it, and I'll be left with minus 5. Now you just need to have a look at that, maybe rewind and play it through again and check you understand each step. You could try it yourself. We'll have another go. We'll have a go at h. Now I'm going to run out of room, I think, here, but we'll see how we go. As you can see, it needs a bit of space. So we'll pull out the 3, leaving me with x squared minus, now if we take the 3 out of that, we'll get left with 2/3 x. Just check when I expand that back, the 3's cancel and I get the minus 2x term, plus 5 out of 3. And you can just check that when we expand that, the 3's would cancel again and I'd get left with 5. Okay, we change to our square bracket. It's come from x minus. Now I need to halve this, half of 2/3. If you just think about that, I want half of 2/3. And I can see that those 2's would cancel and that would be 1/3. And of course, half of 2/3 is 1/3. All squared. Now just quietly underneath, minus a third will be the minus 2/3 x, and I'd get plus 1/9 if I expanded that. I don't want the plus 1/9, I only want the first 2 terms actually from the expansion. I don't want the 1/9. What I do want is the 5/3. Okay, so writing it a bit neater, we've got x minus a third squared. Now we can change this 5/3 into ninths by timesing by 3, top and bottom. If I did that, that would be 15, so I'd get minus 1 plus 15, minus 1 plus 15 would be 14 thirds. And now we need to, or 14 ninths, sorry, and we'll just change that. Of course we're doing it in ninths, you can check that for yourself. And now expanding back into the brackets, we'll end up with 3 times x minus a third squared, and timesing by that, the 3 will cancel with the 9, leaving me with 14 over 3 this time. You can try some more of those.